Okay, what we're going to be working on here is section 5E. We should get a fair chunk of this done today. We're going to be talking about two ideas that are very important to keep separate one from the other. The one is correlation and the other is causality. They are very different. I don't know if you've read this paper. Did you get one, Emily? Okay. Okay, I guess I'll Riley, here you go. Anybody else need one? Darren. There you go. Mine, Elijah. There we go. Okay, so everybody has one of these? I meant to get you one earlier, Emily. I apologize.
It's okay.
I wasn't trying to. Okay, if you take a look at this, it's titled Beware the Dangers of Pickles. Oh my gosh, pickles. Yeah, did you know that they contain indehiscent pepto? Anybody ever told you that? Dude, you know what you're eating? That thing has indehiscent pepto in it. What? Oh my gosh, I've been eating indehiscent pepto? I didn't know that. Okay, there are some staggering statistics. Zooming on down, look at the bulleted information in the center of that paper. Nearly all sick people have eaten pickles before they got sick. It's true. Obviously, pickles cause people to get sick. And if you go on down there, of all the people who died from cancer, 99% of those people ate pickles. So obviously the big cause of cancer is pickles. And if you go on down, okay, 100% of all soldiers have eaten pickles. Oh my gosh. So pickles must cause war. This one's scary. I think of this every time I walk through an airport and I'm getting ready to get on a plane to go present someplace. 99.7% of all people involved in air or traffic accidents ate pickles within 14 days preceding the tragedy. Think about that the next time you get in your car or you get on aircraft. Okay? 93.1% of all juvenile delinquents were raised in homes where pickles were served on a regular basis. It's true. How many of you are going to give up on pickles? Go to McDonald's and order your sandwiches. Don't you care? I mean, look at that. 99.7% of all auto accidents? Aren't you afraid that when you're eating McDonald's, you're going to get in a wreck? Okay, you drop it. And, oh, crud, where'd it go? Okay. I guess that's distracted driving. These things are silly. While there is a correlation between the two, the thing that we want to be careful of and that you need to be mindful of when you are given information is not just is there a correlation, but is there a cause and effect relationship between the two? Okay? Is there a cause and effect relationship? What makes these things regarding the pickles so silly is we all know that pickles do not cause air traffic disasters. True? Okay? There's nothing to do with it. Do pickles cause kids to grow up to be juvenile delinquents? Well, only if they like them so much they slide in and steal them. Okay? But you know that this stuff is silly. When you are given information, you need to weigh carefully, not just is there a correlation, but is there a cause and effect relationship? Sometimes establishing a cause and effect relationship can be a very difficult thing to do. I love this comment. Smoking is one of the leading causes of statistics. Back in the 1940s, movies, and if you watch the old black and white movies, it wasn't uncommon for folks in those movies to smoke. The old cowboy movies, they were rolling their cigarettes and smoking them. Okay? I think it's against the law now in the United States to have a movie where it shows somebody smoking. Wow. So things have really changed. Where things changed is when they finally had enough evidence to be able to make a statistically significant and accurate statement that smoking causes lung cancer. The first thing we need to figure out is, what does this even mean? Does it mean that if you smoke, you're going to get lung cancer? My dad died at 85 of other causes. He smoked, pipe, cigars. Never got lung cancer. There's a comedian who passed away a number of years ago, George Burns, died at 101 or thereabouts. Smoked his whole life. One of his trademarks as a comedian was to come out with a big cigar. Always had a cigar. Smoked his whole life. He never died of lung cancer. Well, there are two instances right there, right off, where I can think of people who I knew smoked. They never got lung cancer. So what does it mean to make a statement that smoking causes lung cancer? Clearly, it doesn't cause it 100% of the time. What it goes back to is the idea of like predicting the weather. When they say there's a 70% chance of rain, does that mean it's going to rain? No, it just means that 7 times out of 10, when the clouds and the weather and the winds look like they do now, in the past, 7 times out of 10, it's rained. Okay? Same thing with this. When they say smoking causes lung cancer, it's like saying there's a 70% chance of rain. Well, 7 out of 10 who smoke are going to get lung cancer at some point. Early, late, who knows? Okay? So, before you can make a statistical statement like this, you need to show that the behavior really does lead to an increased likelihood of the outcome. And you have to do a study or studies that really do link the behavior to the outcome. One of the things that made it very difficult, well, several things that made it very difficult to prove that smoking causes cancer is smoking is not a behavior just that involved men or just that involved women or just that involved the United States. It involved both men, or does involve both men and women. And is it something that occurs worldwide? Yeah. So in making a statement that smoking causes cancer, you've got to control for all kinds of other things that might be the root cause. For example, in this area, we have some concern of radon gas. Radon gas? I know about regular and mid and premium, and there's, there's the green nozzle of diesel. Make sure you don't stick that in your car. But what's this radon gas? Well, radon gas is the result of uranium breaking down. Dude, we don't have uranium around here, do we? Yeah, we do. It's in the ground, just not in big enough concentrations to be a problem. Okay? So what they had to do in doing studies around here, around the Midwest, was to show that it wasn't the radon gas that was causing lung cancer. In various cultures, genetically, are they the same as us? Or are there variations? There are variations, aren't there? If there weren't differences, how could you do the DNA test and say, oh, look, you're 47% Hungarian, 32% Greek, and if there weren't differences, they couldn't pick those things out. Those differences in genetics predispose people to being more or less likely to get certain diseases, to being this, that, or the other thing. Having certain hair colors, certain eye colors, all kinds of stuff. Okay? So, when you're looking at statistics, when they finally got around to the point where they said, yeah, it's safe to say that smoking does increase likelihood of lung cancer, they first had to demonstrate that there was a correlation between smoking and lung cancer. Had to accomplish two things. One, prove there's a correlation. People who smoke more tend to more frequently get lung cancer. Then you got to go beyond that, and this is where the thing with the pickles broke down. You've got to show there's a cause and effect relationship, that the one thing leads to or causes the other. That smoking does have some characteristics associated with it that lead to cancer, like some of the tars and chemicals that come into your lungs and get deposited there when you smoke. Okay. Let's talk about correlations first. What is a correlation? What a correlation means is that as one of the variables increases, the other one increases as well. For example, come home, and Daniel's unloaded the dishwasher and say, "Whoa, thanks, dude. Let's go get some food at McDonald's." Next day, come home, "Whoa, look, the dishwasher's unloaded. Thanks, let's go get some food at McDonald's." Pretty soon he's going to start to relate unloading the dishwasher to what? Food at McDonald's, his favorite place. Okay, he's going to start to correlate unloading the dishwasher and getting to eat at McDonald's. Okay, the one thing seems to cause the other, and as I unload the dishwasher more, I get to go to McDonald's more often. Another thing can happen, okay, his first one is called a positive correlation. As the one increases, so does the other. The other thing can happen is the one thing goes up, the other thing decreases. When the kids were littler, we had to teach them, don't use crayons on the walls. But I wanted to make a neat picture for you. Yeah, well, we just spent $300 turning that into a freshly painted wall. Okay? So things like, okay, if you write on the wall again, we're going to take the crayons away for a week. And stuff like that started to come into play. Discipline. The objective is, as the discipline increases, the unwanted behavior will decrease. This is a situation where you have a negative correlation. Okay? When you look at studies, there are bunches of different letters that are used in the studies. One of the letters that are going to be used is N, and it might say something like N is equal to 250. N talks about the number of people or the number of items involved in the study. So for example, if you were studying light bulbs and N equaled 250, there were 250 light bulbs involved in the study. Okay, so one of the things you want to look at is how many were involved. If it's just one or two, it's not much of a study. You want to have a representative sample. Something big enough to make sense. A second number that comes into play is P. P talks about how likely is it that the survey or whatever really does reflect what we're claiming it reflects. We talked about this earlier. You want P to be 0.05 or smaller. So something like P equals 0.2 or 0.1 is even better. What P equals 0.5 means is there's a 5% chance that this is wrong. That means there's a 95% chance that this is accurately reflecting what we think the population looks like. 0.02 would mean there's a 98% chance that it's accurately reflecting what we think the population looks like. Okay, so we've got N, we have P, in rolls R. R is going to be something like negative 0.85. That would be fairly strong because R does not go any lower than negative 1. It does not go any bigger than positive 1. R runs on a number line ranging from this negative 1 to the positive 1. Negative meaning there's a strong negative correlation. As one thing goes up, the other goes down. 1 being positive as one increases, the other increases. And right here in the middle is 0. Okay? 0 means there's no correlation. The one thing does not affect the other. For example, taking Lorna's crayons away from her does not affect the price of new Dodge pickup trucks. Does it? Probably not. Okay? They are completely separate from one another. There's no correlation. When you are looking for correlation and want to see if it's positive or negative, one way to look at the data is to create what's called a scatter plot. That just means you take each of the data points and you plot them on a chart. Here's an example of a scatter plot. Does it look like there's a pattern there? The data all seem to pretty well fit a pattern, don't they? And it's pretty tight right in that area. There are some where it's a little bit of an outlier, a little bit higher or lower than the main cloud. But for the most part, they're all in a pretty tightly packed cloud. Now, if you shop around the edges of this and you take a look at, oh, okay, the horizontal axis is men's age and the vertical axis is the wife's age. Would you expect there to be a correlation there? Okay, let me put it to you this way. You're out at the beach, and along comes an 85-year-old guy with a 23-year-old wife on his arm. Some of you are already grinning about that, and yeah, well, that's kind of a little on the unusual side. That doesn't happen too often, does it? And you're thinking, you know, somebody's figured somebody else is going to be dying soon, and they're going to be the one driving the Mercedes or the Rolls or whatever it is. Okay? You can find situations where it's 75 and this, or the lady is way up there and the guy is 30-ish. But those are very unusual situations. There typically is a fairly strong correlation between the age of the two people. Okay? This would be an example of a strong positive correlation. R here, I'm guessing, might be like 0.9, which is pretty strong. They don't necessarily have to be positive. Here's an example where you're comparing the number of drinks a person has had to their score on a dexterity test. You know, something like close your eyes and put your fingers together. Okay, I'm trying. Okay. You know what happens. You've probably seen it at some point. Lauren and Daniel have been up to Oxford on a Saturday night and seen some of the foolishness that goes on up there. Okay? As the number of drinks increases, what happens to the dexterity? Goes down. It's pretty predictable, isn't it? Which is why they write tickets for driving while drunk. Because it's pretty predictable. If you're drunk and you're driving, there's going to be some metal bent. Maybe people hurt. This is going to be a situation here where it's fairly tight, but it's negative. So here, R might be something like a negative 0. We'll call this 0.9 here. Not every correlation is quite that strong. Sometimes the correlation is kind of hard to see, and a computer can examine the data and pick out a line where it's hard for us to see. In this one, if that red line wasn't there, would you have guessed that that's really what is going on there? It's hard to see there, isn't it? It just looks like a big blob. There actually is a little bit of a tendency for there to be a slight increase. Well, gosh, what's this about? It's a relationship between folks being married and happiness. One of the things I keep telling my kids, if you're not happy single, you will not be happy married. Happiness is not about the other person making you happy. Happiness is about what you choose to make a life. Okay? Whatever's been dealt to. Okay, this has a slight positive correlation. Notice here, it's 0.363, and you may be saying, well, wait a minute, dude. Back up a minute. You just told me that P was something else. That letter there, that's not a P. That's the Greek letter. Does anybody know what that letter is? It's lowercase rho, R. Really? Yeah. So you got to be careful. It kind of looks like a P, but it isn't. The correlation is 0.363. That means there is some correlation, but is it really strong? No. It means that married folks have a little bit of a tendency to be happier, but it's not super strong. It's not like I'm going to go from completely depressed to elated by getting married. Okay? That's just not going to happen. Does that make sense? Everybody okay? You're good with the December budget? I'll get your quizzes back to you on Wednesday. Folks, I hope you have a good day, and I'll see you on Wednesday.